Picking up where we left off, let's now dive into a few more challenging examples and get some more experience with doing implicit differentiation. So the instructions simply say find dy over dx, and we'll start with part A. 3y to the third plus 4 equals 5x. So we're going to follow our two-step process. We're going to begin by taking the derivative of both sides with respect to x. And so I like to begin by simply writing d over dx and then some big brackets around the left side there, and it equals d over dx and some brackets around the right side. So that's telling me I'm about to perform the derivatives of each one of these. Okay, let's go for it, and I think I'm just gonna show you what we've got here. Okay, so let's take a look at where this came from. So on the left, looking at 3y to the third. Okay, so that derivative, we're gonna begin by doing it normally. Right, the 3 multiplies down, it drops to a square, 9y squared. But now since it was a y, we then attach dy over dx. We multiply that on the end of the 9y squared. What about the plus 4? Well, the derivative of the plus 4 would be 0, so we don't need to write anything there. And on the right, well, that's something familiar. That's just an x, so the derivative of 5x is, of course, 5. So to find now dy over dx, all we got to do is isolate the dy over dx, and that's pretty simple to do here. 5 over 9y squared is our derivative. In this problem, we're not asked to find the derivative value at any particular point, so we'll just stop here. All right, one thing that students often ask at some point during this lecture is, hey, do we need to write dy over dx? Could we write y prime? Is there anything wrong with using y prime instead of dy over dx? And the answer is no, there's nothing wrong with using y prime, although I'll give you a reason why I don't do it and why I don't recommend students do. But maybe at this point, you know, okay, you're taking the derivative and you can see it's 9y squared, and then instead of writing dy over dx, you prefer to write y prime, and then that equals 5. And then when you divide, you get y prime equals 5 over 9y squared. Nothing wrong with that, that's perfectly correct. But here's why you don't see textbooks present it this way, and usually instructors don't present it this way. Pretty much always we go with the dy over dx, because it's too easy to confuse y prime with y to the first if you're not careful. So you really see the dy over dx notation. Although if you prefer this way and you feel comfortable with that, nothing wrong with that at all. Also, you know, the dy over dx, it really stands out, right, in that equation. 9y squared dy over dx, like that looks so much different than anything else. It's hard to miss, where y prime looks so much like y to the first, you know, that it sort of blends in, where this like jumps off. Okay, anyway. So I like the dy over dx myself, and I recommend that to students, but there you go. All right, let's try now another one. We're trying to get more difficult as we go. That's the idea usually. Part B, what's going on here? 2x to the fifth y squared minus 16y equals 0. So we'll begin with step number 1, or at least setting it up. D over dx applying to the left equals d over dx applying to the right. That means we're about to take the derivative with respect to x to the left side and to the right side. Now, how is this one a step up in difficulty from what we've been doing? And take a look at that very first term, 2x to the fifth y squared. Something's going on there that's easy to miss we are multiplying 2x to the 5th and y squared. That's a product. And so for that first term to take its derivative, yes, we need the product rule. Let me bring my camera down a little bit, maybe make that a little bit larger. 2x to the 5th times y squared is a product. Don't overlook the fact that you need product rule right there. Okay, so let's see how it plays out. So let's talk through this one. Starting with that product rule. Okay, so if you remember, product rule says take the derivative of the first piece. Well, in this case, that would be 10x to the 4th. And then we just copy the second piece, which is y squared. Then we add and we do the reverse. We copy the 2x to the 5th, and we multiply it by the derivative of y squared, and we know the derivative of y squared is 2y times dy over dx. So this whole thing here is our product rule. Then we move on to the minus 16y, so we'll subtract. What's the derivative of that? Well, let's see. The 16 is a constant multiple, so that's going to carry along. And then the derivative of y is dy over dx. So again, we took the derivative, we took the derivative as normal, 16, and then we attached dy over dx. And then we can move on to the right side. This equals, well, the derivative of 0 is 0. Okay. So at this point, we have taken the derivative of both sides. I think we can simplify a little bit. I'm really looking at this middle term here. We can multiply those twos. Let's do that. And I've got some dots. Let's get rid of those dots. Okay. Moving on. Got this little gnat. This won't leave me alone. Okay, moving on from here. Once we have it simplified, now we need to isolate dy over dx. How are we going to do that? Like, oh wow, yeah, we need to get dy over dx by itself on one side, and there's two of them. Ooh, okay, so here's what we do. The term that does not have dy over dx, let's move it to the other side. Okay, so we've got 4x to the 5th y, dy over dx, minus 16 dy over dx equals, and when we subtract that, negative 10 x to the 4th y squared. Why would we move the term that does not have a dy over dx to the other side? Because we're now going to do something here, but with these two terms. With only these terms remaining on the left side, they both have dy over dx. What we're going to do, this would be a lot more fun if we were all in class together and I could kind of put it out there. What should we do, you guys? But I'm just going to tell you, we're going to factor it out. Factor the dy over dx. So that leaves you with 4x to the 5th y minus 16. All that quantity times dy over dx. And that equals negative 10 x to the 4th y squared. And then to finish this off, well, once we have it factored, then we can divide that whole thing underneath. And for this problem, dy over dx equals negative 10x to the 4th y squared over 4x to the 5th y minus 16. And we got it. Now that's a derivative right there. Negative 10x to the 4th y squared over 4x to the 5th y minus 16. Wow. Okay. So what we learned here, watch out. Product rules especially can be sneaky. But you might see homework questions with quotient rules. And so be careful there. Don't all those rules that we've been learning, chain rule as well. All of that can come into play in any question with involving now x's and y's. Okay, so be diligent, right? The most important step in this problem was that very first step, taking the derivative. I recommend, a lot of students don't like to write the d over dx, like I've done. They like to just dive right into the derivative, and you can certainly do that. But I'd recommend slowing yourself down a little bit. Even though this doesn't really get you anywhere, right? You haven't actually executed any derivatives at this point. It slows you down a little bit and lets you think and look at those equations a little bit longer, a few more seconds. And so where, you have time to digest what's happening and what rules might come into play instead of, the mistake a lot of people would make is just taking that derivative times that derivative, right? And missing the fact that it was a product rule. So slow yourself down a little bit, take a lot of time with that derivative. Because, that's the biggest step in this problem. And then, solving, okay, there's a bunch more algebra steps to do, sure, but get that derivative done correctly. And don't miss whatever rules need to be performed. Okay. What else might you see? Well, maybe you don't just want a derivative, dy over dx. Maybe there's more to do, right? You might need to find the slope of a tangent line. Certainly. So let's take a look. Hey, this one involves a natural log, and we've got a fraction. Okay. Find the slope of the tangent line at the point 2, 1. And we're going to look at the natural log of y plus x over y equals y plus 1. Also, a fun thing to do with these implicit equations, you can graph these at Desmos, the Desmos website. You can type it in just like that. Natural log y plus x over y equals y plus 1, and it'll give you the graph. It's really sweet. Okay, let's go for this derivative. I'm going to write d over dx applying to the left equals d over dx applying to the right. Slow down a little bit. Let's do this correctly. Okay, now we can see, all right, I've got a natural log of y, so we got to be careful there. Here we've got a quotient, so that will need quotient rule. And then this one, well, still be careful with the y, but nothing terribly crazy going on there. Okay, let me show you the derivative, and let's talk through it. A lot of y's here, so we got to be very careful. Okay, natural log of y. Let's start with that. So take the derivative as normal. It would be 1 over y. But since we just took the derivative of a y, we then have to attach dy over dx. Okay. Then we add and we move on to the fraction. That's a quotient rule. So let's talk through the quotient rule here. Quotient rule is low, which is y, times d high. Well, derivative of high in this case is just 1. Derivative x. Okay, so low d high minus high is x times d low. Well, the derivative of y, dy over dx. Low d high minus high d low all over the low squared, y squared. There's your quotient rule. And it is equal to derivative of y, well, that's simply dy over dx, and derivative of the plus 1 is 0. So there we go. Okay, well, yeah, looking at that, we have successfully performed the derivative, but now we'd like to isolate the dy over dx, and we've got our work cut out for us to do that. that's okay. We can sift through this algebra. We can do it. Here's what I recommend. When you look at this, what really bothers me the most here about solving for dy over dx is that denominator y squared. Honestly, nothing else really bothers me all that much. Now that, after doing the previous problem where we factored the dy over dx out, it's this big denominator, that y squared. I don't like it. Okay, so how are we gonna take care of this denominator? How are we gonna make it go away? What we're gonna do is multiply both sides of our equation by that very denominator, y squared. And it looks like I picked that up on the next page. Let's try and leave that on the screen. Okay. So multiplying both sides by y squared. Well, really that boils down to multiplying each of the three terms by y squared. So when we multiply y squared by the 1 over y, well, we get y, dy over dx. When we multiply the y squared here by this middle term, it cancels with this y squared, and all we're left with is y times 1, well that's y, minus x dy over dx, just the numerator. And when we multiply the y squared by the right side, well, that's y squared dy over dx. So just like that, our equation, I should say, really cleans up a lot. What are we going to do from here? So I see three terms that have dy over dx and one term that does not. The y is the only term that does not have a dy over dx. The others do. So we're going to get all of the dy over dx terms on the same side, and we're going to leave the y by itself on one side. The purpose of that is so that on the dy over dx side, we can factor it. I think the easier way to go here is to move these two terms over to the right. So I'm going to subtract the y times dy over dx, and I'm going to add the x times dy over dx. And when I do that, they'd all be over here, and we could factor out the dy over dx, leaving y equals y squared minus y plus x, all times dy over dx. And certainly you can show that step in between. I think hopefully you can follow my work here. And then, well, we're just one step away. We're just going to divide that over. So y over y squared minus y plus x equals our derivative dy over dx. So we've got our derivative there. Now we wanted to know the equation of the tangent line at the point 2, 1. So we need to begin with the slope at the point 2, 1. Well, we can do that by plugging in our x is 2 and our y is 1 into our equation. So at that particular point, dy over dx equals 1 over 1 squared minus 1 plus 2. And, well, these 1's cancel out, and we end up with just 1/2. Actually, I look back, all they wanted was the slope of the tangent line. So there we have it. There's the slope of the tangent line. Well, we've come this far. Let's get the equation of the tangent line, and I couldn't resist. I went ahead and did that as well, even though it's not what they're asking for. There it is. We've got the slope, and really at this point it's just the same as what we're used to, right? It goes through the point 2, 1. So we can say y minus 1 equals 1/2 times x minus 2. Simplify that, and it actually works out to just y equals 1/2 x. There you go. What I encourage you to do, and what I would do for us if we were in class together, go back, graph this in Desmos, natural log y plus x over y equals y plus 1. And also graph your the equation of that tangent line, y equals 1/2 x, and you'll see it pass through the point 2, 1 and be tangent to the graph there. I don't think that's enough for me to warrant an entire video to just do the one problem, but I encourage you guys to do it on your own. Desmos.com, free graphing, online graphing calculator, very nice. Okay, well, that brings us to the end of section 3.5, so go check out the homework and hopefully see some of you in office hours.